So the matrix multiplication of two matrices, say A into B, is defined only if the number of columns of A, that is the first matrix, is equal to the number of rows of B, that is the second matrix. So let's say if A is an m by n matrix and B has to be an n by p matrix. All right, so you see that the number of columns of A is equal to the number of rows of B. So we can actually we can multiply these two matrices, and the matrix multiplication of A and B will result in another matrix C, and C will have the dimension. So you can just think of it like removing n and n from here. So C will have the dimensions m by p. All right, m by p. So, and I'll show you why this is the case in just a second, but let's see how we do matrix multiplication. So let's say I define matrix A as, let's say 1 2 3 and let's say 4 5 6. All right, so A is a 2 by 3 matrix, right? It has got 2 rows and 3 columns. And let's say B is another matrix, which is, let's say 7 8 9 10 11 12. All right, and B is 3 by 2 matrix, right? So clearly the number of columns in A, 3, is equal to the number of rows in B, which is 3. So A into B is going to be a valid matrix multiplication. And let's see how you will end up calculating this matrix multiplication. All right, so to multiply a matrix by another matrix, we need to find out the dot product of rows of the first matrix with the columns of the second matrix. So let me tell you what I mean by this. So let's say C is equal to A into B. Okay, so the first element, that is the element at the first row and the first column, will be equal to the dot product of the first row of A with the first column of C. All right, so this element will be equal to 1 into 7 plus 2 into 9 plus 3 into 11. All right, so I think this will be 58. Okay, so how about the element of C, which is at the first row and second column? So first row means we will actually dot the first row of A, but now with the second column of B. Okay, so that's how we find out the element at the first row and the second column of C. So this element will be 1 into 8 plus 2 into 10 plus 3 into 12. All right, so I think I hope you get the drift, how you are going to solve the problem. So let's say if I wanted to figure out the element at the second row and first column of C. So the moment we are talking about second row, we can take the dot product of the second row of A, and since we are talking about the first column of C, we will take the dot product with the first column of B. All right, so this guy here would be a dot product of this and this. So this will be 4 into 7 plus 5 into 9 plus 6 into 11. All right, and how about the element at the second row, second column? So second row and second column. So second row of A dotted with the second column of B now. So this will be 4 into 8 plus 5 into 10 plus 6 into 12. All right. So I think this will, if you actually summarize this, calculate it, this becomes 58, 64, 139 and 154. All right. So this seems like quite a bit of hairy math, but typically when you actually use any kind of standard packages from MATLAB or Python or R, the matrix multiplication is mostly inbuilt, so you never really have to actually write code to calculate each of these elements by hand. So yeah, so but interesting, so let me come back to something else. So let's say for this, for this multiplication to work, right, what we needed, that the dot products of rows of A with columns of B needs to be calculated, right? And this is only possible if the number of elements, right, if the number of elements in the rows of A, right, is equal to the number of elements in the columns of B, right, which is 3. And we know that the number of elements in rows of A is nothing but the number of columns of A, right? And the number of elements in the columns of B, right, is nothing but the number of rows of B. All right, I'll see you in the next lecture then.